Today we are going to study about second derivatives. I will show you what second derivatives are, and I'm going to show you an interesting property of them. And in the next following videos we're going to study about concavity and how we can use second derivatives in order to find minimum and maximum points on parts of a function. So first of all, what are second derivatives? Second derivatives are basically the derivative of the derivative. For instance, if we have a function y is equal to sine of x squared. Now, the first derivative is going to be equal to, now we have to use the chain rule here. So the derivative of the outside function with respect to the inside function times the derivative of the inside function with respect to the variable, or in this case x. So that will be equal to, let's see, cosine of x squared times 2x. So this is the first derivative, or the derivative of first order. And now the second derivative, this is the notation. Now I'm going to find the derivative of this expression here. Okay, so here we have to use the product rule. So first of all we have, let's see, 2 times cosine of x squared plus 2x, then in brackets, and here we have to use the chain rule in order to find the derivative of cosine x squared, and that will be equal to minus sine of x squared times 2x, right? 2x, since we decrement the exponent of x squared and we replace it as a factor. And if we rewrite this in a more simplistic form, we will get 2 cosine of x squared minus 4x squared times sine of x squared. Now let's look at something a little bit different. This is a graph of a function, and we're going to look this part of the graph from the point A to the point B. So what is the first derivative? First of all, the first derivative tells us the slope of the function. So from the point from A to C, we can see that the first derivative is positive, while at the interval from C to B, we can see that the first derivative is negative. Now what about the second derivative on this interval? Well, we can see that the first derivative from the interval from A to C is actually decreasing. Now why is that? The second derivative actually tells us whether the first derivative is increasing or decreasing, or whether the slope is increasing or decreasing. Now here, since on the interval from A to C the first derivative is positive, you can see that it becomes less and less positive until it comes to the maximum point where the derivative is 0, since the slope of the function is 0, right? So dy over dx is equal to 0. Now on the interval from C to B, we can see that the derivative is negative, and that's because from 0 it becomes even more and more negative. So actually we can conclude that on the interval from A to B, the second derivative is negative, and that tells us that the slope is decreasing from A. Then from the point A it is positive and becomes less and less positive until it gets 0. Then from 0 it gets negative and even more and more negative. And that is all for today.